Hi, welcome to Code Makes It Go. I'm really excited for you to be here because I have an exciting project and we are going to build a Firework controller. I've seen a lot of these Firework controllers for sale on eBay and they cost upwards of $136 and you only have 24 outputs. This controller that we're going to build has 50 outputs and costs less than $100. And we're going to use an Arduino Nano. I know you might be thinking the Arduino Nano does not have 50 outputs, but we're going to fix that by using addressable LEDs. These are the addressable LEDs that I'm going to use for this project, the WS2811s. The nice thing about these LEDs is that you can individually control each LED and their color. Before I got too invested with this project, I wanted to make a quick prototype using this schematic. The idea being that each individual LED will trigger or light a fuse on a firework. Using an analog voltmeter was better for this test, and it showed that this idea could work. After the proof of concept passed, I decided to build little PCBs for each individual LED. To do this, I used an online tool called EasyEDA. As its name suggests, it was actually pretty easy to build this PCB, and I recommend it for any beginner. It also comes with some pretty nice features like auto routing and a 3D view. In addition, you could send your Gerber file directly to a board manufacturer, and it only cost me $9 for 50 of these. I received the boards in about 10 days, and I think they look great. I chose a black PCB to block out some of the light. And even though I asked for 50, I actually got 60 of these boards. So I wanted to show you all the parts that I have for this build. I have the WS2811 50 LED strip, all addressable. Some resistors, the NPN transistors, this is the BC337, the photo transistors, whoops, those aren't transistors, the photoresistors, some connectors, 22 gauge power wire, have a remote on-off switch so you can start and stop their firework display. I have the igniter fuses, and I have the 50 PCB boards. The next step was to build little project boxes for each LED. I made these so the LED can insert on one side and the PCB can snap onto the top. To create these little boxes, I used the AnyCubic Photon, which is an SLA printer. The cool thing about an SLA printer is it doesn't matter if you print 1 item or 10 items, they take the exact same amount of time, which I'll demonstrate here. The default resolution for the SLA printer is 47 microns, which is pretty good, and for under $200 printer, it's hard to beat. Eventually I had all the little project boxes done, and on to the next step. Alright, this is our very first test. I got the board all populated, and I got the fuse connected to here. So when I shine a light on that little photoresistor, we should see this spark up. We also have it connected to our 5-volt power supply. Well, here goes. I'm going to use this light and let's see what happens. Okay, nothing. So the first test was a failure, and I'm not sure why. It took me a while to go back through everything and try to figure this out. So I ran some more tests, and I found out that I wasn't oversaturating the transistor, meaning that not enough current was going through the igniter to spark it. Eventually, I got the right resistor values, and not to my surprise, it worked. Alright, we're going to try this test another time. I changed the resistors again, tested it again, but just like last time, so we'll see if it works. Anyway, fuse is connected. Still we got the 5 volts going, 5.5. So if I plug in our LEDs, I'm thinking whew, still scared me, but at least it worked, finally. Now that everything was working, I had to build 50 of these, and this is what I had to go through for each one. Just finished all 50, building all 50 of these boards. Took about 3 hours straight. Now, stripping all these wires, have to make 50 different connections. Eventually I finished that, got them all connected, and this is what the final strand looked like. The last thing I had to do was build a control box. The idea was that a 6-volt battery would power this, so I added a 7805 to protect the Nano and the relay board. The remote switch was actually a really nice addition, and it allows us to start and stop the Firework display from a distance. This one actually works up to 100 feet. One cool thing that the Nano provides us is that we can program the timing of the Firework display. This can easily be done with an array of times for 50 LEDs. The rest of the code is very simple. If the relay is on, the light of the LED will either be on or off based on the time in the array. If the relay is off, then all of the LEDs will be off. Alright, I'm stealing power from our Lamborghini 6-volt battery pack. I might remember this project. Still working good. Going to our array, and I've got a slow-mo camera so I could time this fuse. Alright, so first step, turn this on. Wait for the green light.
Dad, what are you doing?
And wait for someone gets in the way. Okay, ready? Back up, back up.
Okay, back up.
Alright. Slow-mo camera. Triggering on. Oh my gosh, it worked. The time between the light and the igniter is very small, only 20 milliseconds. Alright, final test. We're going to do 4 fuses, and Emerson is going to trigger it. Ready, set, whenever you're ready, hit the on button.
He did it.
You did? There it goes.
What did that do? Look. Hey, look.
One more.
And now.
What? I'm just doing some final touches, gluing down some corners. But overall, I'm really happy with the boards. Really happy with the controller. Everything seems to work. And out of 50 of them, if 1 or 2 doesn't work, I wouldn't be totally surprised. But for my limited testing, looked like everything was doing good. So all I have to do now is send this off to my friend, and we should get a nice fireworks show out of it.
So Mr. Code Makes It Go asked me if I could help him out on this fireworks project, and I said yes. So let's take a look at what's in the box here, what he sent me. Here we've got the string of LED lights with individual controllers. Pretty interesting, unique setup. Electronic igniters, good. And a key fob from the 1990s. I did some thinking about where I should put the controllers, and originally I thought maybe I could just string them between the tubes, just go back and forth. That might be kind of nice and neat. I wouldn't need to extend the electronic igniter wires. But then I thought they're going to get all full of fireworks soot, and maybe the vibration from the mortar shells going off could cause a problem, cause a wire to come loose or something. So I've decided I'm going to keep them off of the tube rack and mount them onto this whiteboard. I'm going to hot glue them in the same pattern as the reloadable tubes. Alright, now that I've got all the LED control boards hot glued to the board in kind of their right locations, I'm going to do a little test. Alright, we're going to do our first live test with a chicken blowing up a balloon with its butt. Alright, so now that I've got the control board done, the next thing I need to do is take 50 mortar shells, carefully pull out the green fuse, and insert the electronic igniter. Finished loading the mortar shells into the tubes, putting electronic fuses in them. Now I just need to connect the board outputs to the fuses.
Well, that's it for this project. If you thought it was fun, entertaining, or even learned something, please leave a thumbs up. If you have any questions or comments, you could also leave them below. I want to give a big shout out to my friend in North Dakota for helping launch these fireworks. Thought the show looked awesome. You did an awesome job. All right, till next project. Bye.